Hello students, today we will discuss another named reaction and it is Clemmensen reduction. So this one is the Clemmensen reduction reaction. What happens here? In this reaction, aldehydes and ketones, they get reduced to their corresponding hydrocarbons. So in this reaction, aldehydes and ketones are reduced to their corresponding hydrocarbons by the reaction with zinc amalgam and concentrated HCl. So we can say that the reduction of aldehydes and ketones to the hydrocarbons by zinc amalgam and concentrated HCl is known as Clemmensen reduction. See, let our aldehyde is, this one is aldehyde, and when it is treated with zinc amalgam and concentrated HCl, so this aldehyde will be reduced, means it will lose its oxygen in the form of water. And as in the reduction, addition of hydrogen is reduction. So two hydrogen atoms will be added over the carbon. Here this R, C, H, H and H. And we get here a hydrocarbon. As I am taking here aliphatic aldehydes, so I will get the alkane. See, let this time I am taking here a ketone. This one is ketone. And when this ketone is treated with zinc amalgam plus concentrated HCl, so the ketone will be reduced, means will lose the oxygen and hydrogen atoms will be added over the carbon. And here we will get RCr and two hydrogen atoms will be added over the carbon, and the oxygen, it will lose oxygen and oxygen will be lost in the form of water. Again we get here a hydrocarbon, alkane. As I am taking aliphatic ketone, so I will get the alkane. Now this is the reaction. Now we will discuss what's the mechanism, how the reaction occurs here. Let this one is our aldehyde or ketone. This is carbonyl carbon. If at least one H is linked over the carbon, carbonyl carbon, then it will be aldehyde, and if both sides they are alkyl group, so it will be ketone. Now what happens here? This carbonyl group is having some polarity. In this, the oxygen bears partial negative charge and the carbonyl carbon is partial electropositive. Now what happens here? The zinc which is taken here, the zinc gets oxidized. It loses its 2 electrons and turns to the Zn2 plus ion. Now what happens? These 2 electrons which are lost by the zinc, these are taken by the carbonyl carbon, and at the same time, because this bond is already having a polarity, oxygen is second most electronegative, so the 2 electrons of the pi bond carbonyl group will shift over the oxygen. Now what happens here? Single bond will left in between the carbon and oxygen, and as the two electron of the pi bond shifted over oxygen, so oxygen will become negatively charged. Now out of two electrons and carbon will become positive, but as the two electrons donated by the Zn here, so one will neutralize the positive charge of the carbon and other electron taken by the carbon will make it negatively charged. So this type of species we will get. Now here what happens? The HCl is taken. Now what will happen? HCl will dissociate, will form H plus ion and Cl minus ion. This type of two molecule of HCl are there. So we'll get the 2H plus ion. So one H plus ion will form bond with the negatively charged oxygen, while other H plus ion forms bond with the negatively charged carbon. And we will get here C. Now OH and here H. We'll get a alcohol here. Now the two Cl minus sets free here by which are furnished by the dissociation of the HCl will combine to the Zn2 plus ion and forms ZnCl2. Will set free. Now the alcohol thus obtained, this will get protonated. See, in the medium we are taking HCl. So HCl will dissociate forming H plus and Cl minus ion. Now the lone pair of oxygen will be donated to the electropositive or positively charged hydrogen. Means we'll say the alcohol will get protonated. Now here C, H. Now over this oxygen already there was one hydrogen. As the one lone pair is donated to the H plus, so one more hydrogen will form bond with it. And now over this oxygen only one lone pair will left. As oxygen has donated its electron pair, so will become electron deficient and will acquire now positive charge. Now what happens? In order to compensate the positive charge of the oxygen, the two electrons of this CO bond, they shifted over the oxygen, and here the water molecule sets free. And now we'll get here carbon, here there's the one hydrogen, and this carbon will acquire positive charge. Now in order to compensate its positive charge, again here another Zn atom, it loses its two electrons and comes in the form of Zn2 plus. Now these two electrons are taken by the electropositive carbon. This one is a carbonium ion. So one of the electron will neutralize its positive charge and other electron will make it a negatively charged. Means here as the two electrons taken by this positively charged carbons, so one will neutralize its positive charge and other will make it a negative charge. You will get a negatively charged species, and means here it appears like a carb anion. Now this negatively charged carbon will take one H plus ion from the which is obtained by the dissociation of the HCl, and you will get a hydrocarbon will be obtained. See, here during the protonation of the alcohol, H plus is taken by the oxygen, Cl minus is here, and in this step one Cl minus is released here. So these two Cl minus, they combines to the Zn2 plus ion which is formed in between the reaction and will come out in the form of ZnCl2. And in this way, we will get our end product hydrocarbon. Now see, here as we are taking the zinc amalgam and concentrated HCl. See, now here what's the use of the mercury? So remember, here we'll discuss the use of mercury. Why we are taking mercury here? As in the mechanism, only and only zinc and HCl is used. So why we are taking mercury here? So actually what happens here, zinc, this mercury traps the hydrogen which is obtained by the reaction of the zinc and HCl. See here, active hydrogen gas is released. So in order to trap this hydrogen gas, mercury is taken here.